Hey geometry team, this is Mrs. Cerna and welcome to Unit 11, Day 3. And we are talking today about doing proofs of similar triangles. And so the first thing we're going to start off with is reminding ourselves, how do we prove triangles congruent? And remember, you always have three ways to prove triangles congruent. You can prove them using two angles being congruent at the same time. That's angle-angle similarity. You can use side-side-side similarity, where you have all three sides proportional. Or you can do side-angle-side similarity, where you have two sides proportional and the included angle being congruent. And so anytime we see that we're trying to prove two triangles similar, like we have in this first example, we know we're going to be looking for one of these guys. And so to start off, let's look at example 1 and see what we can come up with. So to start off in problem 1, I'm given that segment MN is parallel to segment JL. So I'm going to come over here and say, okay, I know that MN and JL are parallel. And remember, you mark that with the arrows. And I'm going to try and prove that JKL, that's the big triangle, is similar to MKN. That's the little triangle. So I'm going to go ahead and outline those. JKL is this big one, so I'm going to outline it in purple. And MKN is this littler guy. I'm just going to outline it in orange, just so I can tell exactly what I'm trying to prove here. And so I've got some options. I can try and find two sets of angles being congruent. I look for sides being proportional or a mix. Now over in this triangle set here, I don't have any triangles. I don't have anything telling me side lengths. So I can't really set up any proportions of sides. All I have is that segment MN is parallel to segment JL. They gave that to me. That's all I've got. Well, now I can think, well, what can I do with my segments being parallel? And if you think back to the dark ages of a few units ago, when we had parallel lines, their corresponding angles would be congruent. And so that means that these two on these parallels can be congruent. So I could say, okay, angle KMN can be congruent to angle KJL, because those are corresponding angles in parallel lines. All right, so that's one set. I could also, using those same parallels, come over here and say that those two guys are congruent. So I could say angle KNM is congruent to angle KLJ. Again, because they're corresponding. Either one of these would work. Well, once I have both of those, oh look, I can then have angle-angle similarity, because I have two sets of angles congruent. Here's an angle and here's an angle. Alternatively, if I forgot that either of those existed, if I looked and said, oh, my little triangle has angle K up here, and my big triangle also contains angle K. So I could say angle K is congruent to angle K by my reflexive property. Remember, reflexive property means you're congruent to yourself. And that would be another angle that I could say is a set of angles being congruent. So I actually have all three, but I only need two of them. And so since I have at least two angles being congruent, I can say that triangle JKL is congruent to triangle MKN by angle-angle similarity. Any two of those would have worked. So I could have used just these two, I could have used these two, or I could have used these two. Any set would have worked. Moving on to problem 2, let's see what they can throw at us here. Here I am given that I have two angles, EAB, and DCB are right angles. So I'm going to go ahead and mark those in my picture and put them as my given. So angle EAB and angle DCB are right angles. And you know I'm writing it super short because I'm lazy and want it to go fast. And this is something that I have been given. Now I'm trying to prove that the two triangles are going to be similar. And since I don't have any sides marked at all, my best bet is going to be to look for angle. Well, right off the bat, based on my given, if I have two right angles, I know then that angle EAB had better be congruent to angle DCB, because we have shown time and time again that all right angles are congruent. And there's several steps in showing that. You can say that they are right angles, so they add to 90, and then you can substitute, and you can do a bunch of stuff and eventually get to here, but we've already proved that. And so we can just go straight to all right angles are congruent. So now I have one set of angles being congruent in my triangles. So I need one more set being congruent. So you look at the picture and you notice, ooh, I have some vertical angles here that are going to be congruent to each other. And so here on the left, that's ABE, so angle ABE should be congruent to angle CBD, because those are vertical angles. So now I have another set of angles being congruent. Okay, well now that I have two sets of angles being congruent, boom, I'm done. I can say that triangle EAB is similar to triangle DCB because I have angle congruence. That's all I needed to show. So we like it when it's short and sweet like that. Let's try a different one. Let's see if there's something else that comes up. So in number 3, I have segment WY, so that's this guy right here, is bisecting an angle. It's bisecting angle XYZ. And so I'm going to put that in my given. WY bisects angle XYZ, and that's given. I also have that XY, I better get a different color there, XY is to ZY, and that's equal to WY, so this top big one, compared to the one below it. So notice I have big to small equals big to small. Well, that, my friends, to ZY equals WY to VY, that's saying that there are two sets of sides being proportional. I have two sets of side proportional that was given to me. Well, if two sets of sides are proportional, that gives me a side and a side right there. So I have a side and a side are proportional. So all I need is either a third set of sides being proportional, or I need a single angle to be proportional. So I can use one of these. Well, looking back here, I have bisected an angle. And when I bisect angle XYZ, that means I cut it into two congruent angles. So angle XYW is going to be congruent to angle WYZ because I cut it in half. When you bisect something, the two halves are congruent. That's the definition of an angle bisector, is it bisects the angle into two congruent angles. Well, that gives me a set of angles being congruent now. So, and it is included between the two sides that are proportional. I have a side and the angle between them. So therefore, I can say that triangle WXY is similar to triangle VZY by side angle side similarity. Short and sweet. Moving on to number 4 now. Let's see. This one, oh, I've given you a few more spaces here, so this one might be a little bit more involved. So let's see if we can figure out what we're going to do from the beginning. And looking up here, I'm given some parallel lines. I'm given PR is parallel to ST. Okay, so PR is parallel to ST. That was given to me. And so right away, since I'm seeing parallels, I'm thinking, ooh, maybe I'll have some congruent angles to use in proving my triangle's congruent. So let's get excited and see if we can find some congruent angles. Since these lines are parallel, they are being cut by a transversal, so these alternate interior angles are going to be congruent. So I can say angle QPR, that's this guy right here, is going to be congruent to angle STU because those are alternate interior angles. So alternate interior angles are congruent. Well, that's a set of angles. So I either need another set of angles congruent or I need a set of sides to be proportional. And so I look through here and go, okay, I know that UT is 2 PQs. So that was given to me. So UT is 2 PQs. I also know that ST over here is 2 PRs. That was also given to me. So ST equals 2 PRs. Both of those were givens. Well, now this right here, this section is only going to be 1 PR. This is PR, and there's only 1 PR here because that's what it is. It's PR. And this right here is PQ. So I'm going to set up my ratios. I'm going to set up this one to this one because these are going to be my corresponding sides. So I have 2 PQ going to PQ. Well, that ratio simplifies down to 2. And then with my orange guys here, ST is going to be matched up with PR. Well, ST is 2 PRs matched up with a single PR. And when I simplify that ratio, it also comes down to 2. And that's just using my division property. I divided by the same thing on top and bottom. That comes from your algebra. Well, now I have 2 proportions that are congruent to each other because 2 PQ, this one right here, was UT to PR, UT to QP, UT to QP. And this one is ST to the PR. And so these two are both equal to 2, therefore they're equal to each other. UT to PQ and ST to PR. This set equals 2, this set equals 2, therefore they equal each other. You could say that that's substitution. Or if you wanted to, you could say that was the transitive property because 2 things equal to the same thing are equal to each other. Either one of those will work. Well, now I have 2 sides that are proportional to each other. So that gives me a side and a side, the green and the orange, with the included angle. And so that gives me my triangles are going to be, I didn't want to put equal, I wanted to put similar to triangle TUS. Let me just mark that out there. And that's going to be by side, angle, side, similarity. Alrighty. Number 5, ooh, even more spaces. Don't panic, it's not going to take up that much space. So I'm going to start off and look at what I'm given. I'm given that the measure of angle ACB is 110 degrees. And then I'm given that the measure of angle CDE is 40 degrees. So this guy right here is 40 degrees. And the measure of angle B here is 30 degrees. So that's this guy right here is 30 degrees. Already, since I'm being given so many angles, I'm going to probably go off the assumption that I'm probably going to use one of my congruency things that uses angles, either angle, angle, or side, angle, side. Similarity. Well, since I don't have any sides, I'm going to shoot for finding 2 sets of angles being congruent, so I can use angle, angle. So I'm going to start off by listing all my givens. I've got the measure of ACB equals 110. I've got the measure of angle CDE equals 40. And I've got the measure of angle B is 30. And all of this is given to me. And so then I look at this and I go, well, wait a minute. In this bottom triangle, so my smaller triangle, triangle DCE, which is one of the two I'm trying to prove similar, I have two of the angles. So I can find the third angle. And so I can go in and say right away that the measure of angle, the measure of angle CED is going to equal whatever I get from subtracting from 180. So I've got 110 plus 40 equals 150. And when I do 180 minus 150, I get 30 degrees. So I have 30 degrees for this angle. And this is because of our triangle sum theorem, which tells us that triangles add up to 180. And then we did a bunch of algebra. And instead of showing all those algebra steps in the proof, we're just going with the triangle sum theorem tells us that they add to 180. So I've got this guy right here equals 30 degrees. Oh, well, look, now I have a 30-degree angle and a 30-degree angle. So I have a set of angles right here being congruent. So I can say that angle CED, this little guy, is going to be congruent to angle CBA. And that's from, being congruent. They are congruent to each other. And so let's go with substitution. Because here I have one of them equals 30, the other one equals 30. So I had CBA or angle B, that's this guy was 30. This guy was 30. And so they're congruent to each other by substitution or the transitive property. Okay. Then I can look at my picture and go, now wait a minute. My big triangle contains angle C, and my little green triangle also contains angle C. So I can say that angle C is congruent to angle C. And that's going to be by my reflexive property. So now I have one set of angles being congruent and another set of angles being congruent. So I'm ready to be done and say that triangle ACB is similar to triangle DCE. I could also have, if I wanted to, use the same triangle sum theorem and found that this angle up here was also 40 and used it as one of my angles in the triangle. I could have used that as well instead of doing this one where I found it being 30. I could have used this one and found it equaling 40. So there were options here on which set you wanted to try, and it doesn't matter. You get to pick which ones you like to try, okay? And this was by angle similarity. I almost forgot to write the reason. Mrs. Cerna, you got to write your reasons in. You don't get to leave it blank, okay? Number 5. Let's see. Let's try number 6 here. This one looks nice and short. So again, let's figure out our plan of attack. I'm given that LM, so L to M, that's this guy, is in a ratio with PQ, and that ratio equals MN to QR. So those two are proportional. So, oh look, I have a set of sides proportional. And then I have that the orange ones are in a proportion with the purple guys. That's another set of sides. So wow, I am pretty much being given everything I needed to. Oh, but I'm not trying to prove the triangle's similar. I'm trying to prove that angle N is congruent to angle R. So in order to get there, I can go through similar triangles. I can say, well, if my triangles are similar, then I know that their parts, their angles have to be congruent. Okay? Because that's what the definition of similar triangles is that if the triangles are similar, their angles are congruent. So let's get going. Let's start with what I was given. I was given LM to PQ equals MN to QR equals LN to PR. That was just given to us. Well, that gives me sets of sides being proportional to each other. So I can then say that the two triangles are similar. Now I have to put everything in the right order. So let's start with this one. I'm just going to do it in alphabetical order. So LMN. I'm going to say it's similar to the other one. So if I go from L to M to N, that goes from blue to orange. So I need to go blue to orange. So PQR. We've got to put corresponding parts together. And I can say this is true because I had the side was proportional to this side, which is proportional back to the other one. So I have side, side, side similarity here. Now that I know the triangles are similar, now I can go in and say, okay, if they're similar, then their corresponding angles are congruent. So angle N has to be congruent to angle R because corresponding angles of similar triangles are congruent. And that's it. That's all you have to do on that one, is you just have to get them similar so that then you can say their parts go together. All right. A couple more I think we'll walk through just so you can get a feel for how the thought process works on these. So for number 7, I'm given that RS is congruent to ST. RS is congruent to ST. Now these two are on the same triangle. That's new. And then I have UW is congruent to VW. And again, those are on the same triangle. And then I have angle R is congruent to angle U. Now, then I need to prove that I have proportional sides. I need to say that these two sets of sides are in proportion. So RS needs to go with UW, and RT, so I need to do this guy, I don't know, to go with this guy, and I need RT to go with UV. Okay? So I don't know if those are proportional, but if I can prove that the triangles are similar, then I will know that those are proportional to each other. I'm going to start off with my givens. And I was given that RS is congruent to ST, and I know that UW is congruent to VW. That was just what I was given. And I'm thinking, I need to prove that the triangles are similar so that I can say that these are proportional, but I don't have any lengths here. I do know, however, that I have two sides of the same triangle are congruent. Well, if two sides of a triangle are congruent, that makes it isosceles. And on this one, if I have two sides that are congruent, it'll also be isosceles. So I can now say that I have triangle RST is isosceles and triangle UWV is also isosceles. And that's by my definition of an isosceles triangle because they have two congruent sides. Well, now what can I do with congruent triangles? Well, I know that isosceles triangles, the sides that are congruent, will be opposite angles that are congruent. So I know that this angle on the bottom is congruent to this angle on the bottom. So, okay, I can say that angle R is congruent to angle T. And then on this guy, I can say that angle U is congruent to angle V, because the base angles of an isosceles are congruent. We did that back when we were doing isosceles triangles. And you're like, okay, great. Once again then, I have the angles inside the triangle are congruent. I need to somehow connect the two triangles together to make them be similar. And well, now we can go, okay, I started out with angle R being congruent to angle U. That was given to me. Well, R could be replaced with T. And U could be replaced with V. And so I could then replace everything and say this could be like angle T. And this could be angle V. And suddenly I have T here being congruent to V over here. And that's by substitution, or you could also call it the transitive. Okay? So now I have, just by replacing letters, I've proven a whole other set of angles congruent. So I had a set of angles congruent here. Now I have another set of angles congruent here. Oh, well then I have two triangles being congruent. I can say triangle RST is similar. I should have said similar. I know that it's similar to triangle UWV by angle-angle similarity, because I had two sets of angles congruent. It means the triangles have to be similar. Well, now that I know they're similar, I can say that their corresponding sides are proportional. So now I'm back to what I wanted. I can say, okay, now that these are similar, I can say that RS to UW should equal RT to UV, because corresponding sides of similar triangles are proportional. And so you have to kind of plan ahead, or if you're stuck and can't plan ahead, go a step at a time. Think of something you can do and see where it leads you in each problem. Let's do one more together. Let's do a last one. Let's do number 8. Okay, so our last one. I am given that FE and DE is proportional to GE with CE. So FE goes with DE, and GE goes with CE. So I know those are proportional. That was given. Well, already that gives me two sets of sides being proportional to each other. That's awesome. If I want to prove my triangle similar, now that I've got two sets of sides, I could either go for side angle side or side 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 similarity. Well, looking here, I don't know anything about those other sides, but oh look, I have a set of angles that are vertical. So I could say angle DEC is congruent to angle FEG because they are vertical angles. And that angle is the included angle of my two sides. So now I have a side and an angle and a side. So I can then say that triangle DEC is similar to triangle FEG by side angle side similarity. And so I planned ahead, thought about what I had, figured out what I could use, and went from there. Okay, so now thinking about your homework, you have several sets of problems that you're going to be doing that involve setting up the ratios and looking for equal ratios. You're going to be proving triangles congruent. You're going to be proving parts congruent. And then on this last one, I'm going to have that some triangles want to be similar. And let's just start you off and look at what you have to give you a sense of direction where you want to go. Here I have angle BFG. BFG, that's this big guy, is congruent to angle BFE. So that's this other big guy. And I am also, so let's see, angle BFG is congruent to angle BFE. I also have that angle GAF, right here, is congruent to angle EDF, right here. So angle GAF is congruent to angle EDF. Well, those are angles in totally different places. I have an orange angle in this outer triangle right here, and I have an orange angle in this triangle. But I don't have the individual angle here. I have something that connects the triangles. BFG and BFE are parts of two triangles. So which sets of triangles am I trying to talk about here? Do I want these blue ones on the outside, or these little triangles on the inside? Well, I'm trying to prove this. So I want to prove GAF is similar to triangle EDF. So I'm trying to prove these blue triangles are similar. Okay? And based on what I'm given, I already have this orange set of angles is a set of angles in the triangles I want. If only I could prove that this angle right here is congruent to this angle right here. And this is going to involve the other piece of information they give us, which is BF bisecting angle AFD. If BF is bisecting, that means this half is congruent to this half. So once I've put my given down, so that's my given, I'm going to be able to say that the two halves are congruent. And the clue I'm going to give you is your angle addition property. Somewhere in here, you're going to have to talk about how this big blue angle here is made up of smaller angles. It's made up of the green angles here and this red angle right here. Green and red makes blue. Green and red makes blue. And you're going to have to use that to prove something about those red angles so that then you can prove your triangle similar. So I'm going to leave you to see what you can figure out about that one. Good luck on your assignment, team, and we will see you next time.